What happens when we subtract an irrational number from another irrational number? Let's find out. So we know irrational numbers are numbers such as square root 2, square root 3, so on and so forth, right? So we are going to write down some of the decimal forms of these numbers and use them in our examples. So this will be square root 2 is 1.414 and goes on, non-terminating, non-repeating. Square root 3 is 1.732, non-terminating, non-repeating. Similarly, you can find out what they are, right? Now, the question is really irrational number minus irrational number. So let's say we want to do square root 3 minus square root 2. Both are irrational numbers, right? So how do we solve something like this? Well, what we really have to do is we look at the decimal expansion and write square root 3, which is this one, 1.732, and this goes on forever, minus 1.414, and this goes on, right? And we are actually looking to subtract. Now, because this is going to be going on infinitely, so we really cannot solve entirely, right? But we do know that whatever the number, that will go on infinitely, right? But if we were to focus on the last three decimal places, so we will have here, so we'll have one carryover, 12 minus 4 will be 8. So this will be 2, 2 minus 1 is 1. And here we have 4, 7 minus 4 is 3. And this will be 0. So in other words, we'll get a number like 0.318 dot 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 dot. And this number is, because these numbers have no pattern, similarly these numbers have no pattern, when we subtract one from another, right? So this will be, these numbers will have, they will not be repeating. So we have a non-terminating, non-repeating number, and we know these numbers are irrational numbers, right? So when we actually subtract one irrational number from another, we get an irrational number. Now I will encourage you to do the same thing. Find out what is the square root of 5 in the decimal form, right? If you were to find out, I think it is 2.2 something. So if you were to find out what this is, and similarly find out square root 7, and then what you do is you do square root 5 minus square root 3 and see what you get. You are again going to get an irrational number. You are going to get something that is actually going to be non-terminating and non-repeating. Now let's take a look at some examples, more examples, maybe a little bit different types of examples. Say we have something like, let's do this, maybe square root 3, or let's say 5 square root 3 minus square root 2 minus maybe 3 square root 3. I'm randomly writing these numbers, right? So here we have three irrational numbers. We know when we multiply a rational number and an irrational number, we have seen earlier that we get an irrational number. So what we have here is that we have three irrational numbers. So like the way we discussed when we were talking about irrational number plus irrational number, we are looking for like terms. Like terms in this context means we are looking for similar square roots. So this is square root 3, this is square root 3. So we are going to group them together. So we will write this as 5 square root 3 minus 3 square root 3. We will write them together minus our square root 2, right? Again, remember, like when we were doing algebra, when we learned algebra earlier, if we have, say for example, x plus 2y minus say 2x minus maybe 10y, I'm randomly writing something, plus maybe 10. So the way we solve this is we group the like terms together, which is x and minus 2x. So we will write them together, and then we will write the y terms together, right? So we will have 2y minus 10y, and then we have the constant, the number term. So this will be x minus 2x, this is 1x, so it will be minus x. 2y minus 10y will be minus 8y, and then the plus 10. So this will be the answer. So similarly here, it will be 5 square root 3 minus 3 square root 3. This will be 2 of square root 3. And we will have minus square root 2. Now, 9 out of 10 times, if a question like this is given, you are going to write this as your final answer, right? the question will not expect you to basically find out the decimal form for square root 3 and square root 2 and then multiply the 2 with the square root 3, and whatever you get, you have that minus the decimal form of square root 2. No. 9 out of 10 times, if a question like this is given, you're going to leave it at this, right? And this is an irrational number. Because if you were to really find out, you can just use your calculator and see for yourself that the answer that you will get, the number, the decimal form that you will get, will be non-terminating and non-repeating. So similarly, when you had a question like square root 3 minus square root 2, this actually will be your final answer 9 out of 10 times. Because the square roots are different, you really cannot simplify or solve this anymore. Of course, you can always do the decimal form, right? But we know that the decimal form goes on indefinitely, so it is almost of no use to actually do it that way. Unless the question that 1 out of 10 times they may ask, they may say that show this to the nearest 4 places of decimals. In that case, they may give you the first 4 decimal places for square root 3, and they will do the same for square root 2, and then you will actually subtract square root 2 from square root 3. So what we can say is that irrational number minus irrational number will be always irrational number. But why is there an asterisk? Because what happens when you have square root 2 minus square root 2? This is an irrational number, this is an irrational number. Of course you can do that. The answer is you get 0, right? Meaning obviously if you subtract one number by itself, you will get 0. So similarly, if I have 2 square root 5 minus 2 square root 5, my answer again will be 0. So irrational number minus irrational number will be almost always irrational number, except that when you have both the numbers are same, in that case we will get 0. And we know 0 is a rational number. 0 is not irrational. Why? Because we have seen many times over 0, the number 0 can be written as 0 by 1, and this is basically the definition of a rational number where p and q are both integers and q not equal 0. The denominator cannot be 0, right? We cannot have a number like this, because if 0 is the denominator, that becomes undefined. But 0, if 0 is the number, we can write 0 as 0 by 1, so definitely it's a rational number. So again, irrational number minus irrational number will be always irrational number, except when both the numbers are same, and in that case we will get 0, which is a rational number.